Hi, I'm Anastasia Dalbe. This is SDG Labs. And there's this negative boy who was unsure about going to this radical party. He was kind of a square, and so he missed out on talking to 4 awesome chicks. The party was over at 2 a.m. Alright, here's one here's one where we are going to have kind of 2 pieces of physics mixing up together over here. I'm going to need to use old school kinematics, and I'm also going to need to use this force equals mass times acceleration. There's this thing called foamcrete or something like that. Anyway, it's on the runways, and what it does is it's basically really soft concrete. So cars can drive over it, but if an airplane tends to drive over it, it crushes below and then basically, falls apart. It crumbles beneath the thing. Why would you want that on a runway? Well, let's say if you have a runaway plane, like a plane that doesn't actually have brakes to use. Then what would happen is you have your runway, and at the Honolulu airport at least, the runway goes off, and if you go over the runway, there's the ocean. So you don't want your plane to actually kind of hit the runway and then go too far into the ocean. So what you're going to do is you're basically going to say you're going to put a bunch of this foamcrete stuff, and that's basically going to slow this airplane down. Now, our Boeing 747 apparently I shouldn't say weigh, but it has a mass of 1.75 times 10 to the 5th kilograms. It's a heavy sucker. Its velocity initial before it hits the foamcrete is 26.8 meters per second, and it stops in a distance of 122 meters. Let's pretend that 123 meters, there's the ocean, so hopefully it stops at 122 meters. What did I ask for? What is the acceleration of the plane during its time in that foamcrete? And what is the force that thing applies to it? Let's try it. So what I would want to do is I need to figure out the acceleration first. I have the V initial, I have the delta x, I actually do have the V final. The V final is 0 because the plane stopped. I mean, if the plane didn't stop, then the V final wouldn't be 0. I'm looking for the acceleration. Well, the equation I can use is V final is equal to V initial plus AT. Is that the equation to use? No, because I don't have time. So I think it's V final squared equals V initial squared plus 2A delta x. That's the other one. Alright. V final is 0. V initial is 26. So I'm just going to pull this over, and I get negative V naught squared equals 2A delta x. And so I'm going to divide both sides by 2 in the delta x. And so I'm going to have A is equal to negative V naught squared over 2 delta x, which is equal to 26.8 squared, put a negative out in front there, divided by 2 times 122 meters, and if you were to do that calculation, it would be negative 2.94. Let's make sure the units are correct. This is in meters per second, and if I square that would be a meter squared per second squared. This is 122 meters. So that one cancels out with that one. I'm left with meters per second squared, which is exactly an acceleration. That's the acceleration that I want. Why is acceleration negative? Well, it's because the plane is slowing down on the runway. So its acceleration is in the negative direction. All right, let's throw in this force. Well, we know that the force is equal to mass times acceleration. We have the mass, we have the acceleration. Calculating out the force is just plugging it into your calculator. Alright, fine. Force is equal to 1.75 times 10 to the 5th kilograms times negative 2.94. I don't have enough room for the units. If I were to calculate that out, that would be about 5.15 times 10 to the 5th. Kilograms times a meters per second squared is known as a Newton. And that is your force. It's a big force. So if we had Superman around, and if Superman could apply 5.15 times 10 to the 5th newtons of force, he would stop this airplane in 122 meters. However, we don't have Superman, so we use foamcrete. I think it's a play on concrete, but it's like foam. Anyway, We use foamcrete to stop this thing in 122 meters, and that's how it's done.
Shoots, bro. Up out.